So we're going to kick off today finishing up our lowest surrounding occupants function. All we have left is our middle cases. So let's go ahead and build that out. Now we would know we're a middle case if we got to do a couple things here. We got to say we would know that we're middle case if our origin row, which is the parameter that we're passing in from our movement origin row, if our movement origin row does not equal 1 and our origin row does not equal 5, meaning it's 2, 3, or 4, and our origin column does not equal 1, and our origin column does not equal 5. So if our origin row is 2, 3, or 4, and if our origin column is 2, 3, or 4, then we know that we're a middle case in which we need to check all of our surrounding occupants. So we're going to check one at a time. We need to check up, right, bottom, left. And we're going to say we got to check. We only assign our lowest surrounding occupants if our stone control belongs to a lay stone. So if it's not occupied, or if it's occupied by a capstone or a standing stone, we will not worry about assigning our lowest surrounding occupants because it won't be a legal move anyway. So we can say grid. Now we need a check above us, which would be same column, one row above us. So origin row minus a 1, and our same column. Now we're checking our stone control for equality with our lay stone. And if so, then if we don't have a lowest surrounding occupants yet, which we're checking if it's nil, it hasn't been assigned yet, and if it's nil, then we're going to go ahead and assign that variable to be our grids occupants here. So we can say this occupants, and then we're going to do else if this grid's occupants above us, if that amount of occupants is lower than our current lowest surrounding occupants, then we would also update our lowest surrounding occupants to be this grid as well. Yeah, and we can factor this out, I think, by adding this conditional into this conditional with an or statement. I think that'll work. I'm just a little hesitant because I think it'll crash because of the nil equality, but it could and should just work. So once we get it working, we'll worry about making it pretty like that. So I think that's right. So that should be our up case, checking the grid above us. Now we need to check the grid to the right of us, which would be the same row, but a column plus a 1. So origin column plus 1. We're checking stone control. And we're going to see if this is nil. And if it's nil, we're just going to assign it for the first time. And we could go ahead and copy this. dot occupants gets assigned into our lowest occupants, and then the other scenario is if that grid's occupants to the right of us is a number lower than our current lowest surrounding occupants, and if that's the case, then we are also going to update it. Now we need to check beneath us. So we're going to say else if the one beneath us, which is going to be a row +1, so our parameter +1 here with our current origin column. We're going to check for that lay stone control to see whether or not it would be a legal move. Now we already take care of if it's at our max stones, we nullify that legal move, so we just check for stone control here. And same thing over and over and over, just with the different grids. So we know we need to copy this. We're already almost done with this function, which is nice. But we're going to assign this if the occupants are less than the lowest surrounding occupants, that's when we also update it. Yeah. Okay, last case, which should be to the left of us. And if it's to the left of us, it would be our origin row -1. Wait a second. So here we have what, above us, to the right of us, below us, okay, yeah, and to the left of us. Okay. Now to the left of us would be a column -1. Nice. We're checking stone control, making sure it's a lay stone. If we don't have a value here, we're going to assign it to be this one. We also need to assign that if this grid's occupants is smaller than our lowest surrounding occupants. Now, okay. Just gonna make a little note here for which ones they are. So top, or maybe I would say above. Above. This one is to the right. This one is below. And this one is to the left. Okay. And then I believe we need one more end function to, or one more end to actually, wow, geez, this is a big function. If, else if, okay. This, else if. Okay, we're actually going to do this here. If here. Which means we need to end this. And then we need to end this. And end this. I think. Jeez, okay. That's a big function. All that function does is return the... It actually updates this variable called lowestSurroundingOccupants to be the number of lowest surrounding occupants of a laystone around us. So if that works, I'm just gonna try to run the game to see if it crashes anywhere. Which 488. Why would it crash here? Then expected. You've got it then. I don't know why it's crashing there. 488. Than expected. 488, not 448. 488. We're checking for equality here. So let's try that. Okay, so it runs. Do we have room on our debug 1? Yeah, we've got room on our debug 1 to paste this value to see if it's working. So we're just gonna copy this and we're gonna paste it into our debug 1. Oh my god. Got a different mouse since I'm over at Annie's place. And yeah, I really like the magic mouse after trying to use this thing. I really don't like it. But we're gonna take this on our debug 1. We're gonna go ahead and paste our lowest surrounding occupants here. Okay, and then shift it by one line. Now, oh my god, whatever. Okay, it should be nil right off the bat, which we can't even read it because it's printing off screen, so we'll just do lowest surrounding occupants. Should be nil, which it is. So as soon as we lock in our movement origin, we need to run this function, pass in the appropriate movement origin parameters, and then hopefully it'll go around. If this is our movement origin, it'll go around. Since it's a middle case, it'll go through every 4 orthogonal space, and this will be a capstone, so it won't care about it. This is a stack control or a stone control. Oh, see, stone control is actually a stone type, not a color string. So I'm curious if we wrote our function wrong for our tester stacks. Let's make sure we do that correctly. Now, if we look in our tester stack function, Come on. Where do we put it? Obstacle populate, see stone type. Stone type. Stone control and stone type. That should be okay. Oh, see, look, this stone type. Oh, no, no, no. Huh? We're giving a string here of our stone type. So when we're printing up, oh, stone control, hold on. When we're printing up stone control, let's look at our stone control. Yeah, we need, we're passing in the stone color for our stone control in this tester. When we need to be passing in the stone type. Now that should give us the correct stone control. Which now we've got a laystone, 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 and capstone. So that seems to be working. So when we implement this function we just wrote, I'm hoping once we lock in this spot as our movement origin, it'll go by and count, 13, it'll start off lowest surrounding occupants 13. 13 gets to 11, and since 11 is lower than 13, it'll hopefully save this lowest surrounding occupant field as 11 instead of 13. No matter where this 11 is around it, it should be the lowest occupant, lowest surrounding occupant number. So where do we need to actually use our function? We're going to take, now our function takes in just two parameters, an origin row and an origin column. So I'm pretty sure as soon as we have our movement origin, we need to do this. So we'll say movement origin row. So right here, when we click, what movement event is this? Movement event 1. Because that's when we click on a stack in our control, and it's not above a 14 stack. Now, so if we click an illegal move, then we're going to go ahead and run this lowest surrounding occupants on our newly founded movement origin row, movement origin column. So we should be able to say movement origin row, movement origin column here. But then we need to actually, when we press, when we swap players, we nullify our lowest surrounding occupant variable. So we might be good. That might be all we need to do to do that. Let's see. So it should be nil right off the bat, which it is. Remember, we're looking here at this lowest surrounding occupant value. Now we're hoping that since there's a 13 stack, a capstone, and an 11 stack, that once we select this, in a move type move, once we click on this, we're hoping that this value will become 11. And it crashed. So global. So we crash at 8:58. Let's see what that is. We crash in the function call. And we crash because it says attempts to call lowest surrounding occupants. Now this is the actual function. Attempts to call global lowest surrounding occupants, which is a nil value. So maybe, we should have defined it before. You know, yeah, we defined it here above. Lowest surrounding occupants. See, I'm wondering if this is, if it's crashing on this nil. I don't know, man. That's why we try to get around that bug. So I think it's crashing on the function call because it says attempt to call. But why would the function be a nil value unless we spelled it wrong or something, which we literally copied and pasted it from here. Lowest surrounding occupants. Lowest surrounding occupants. We have it. What if we just put a 1 and a 1 here just for testing purposes? Huh? So why does it not crash there yet when we put our movement origin row and movement origin column? See, that should be that's going to be a number. And now it's not crashing. Well, I guess it only crashed when we clicked on it. Okay, let me try. The 1-1 and click on it. I just don't know why it's crashing. Yeah, it doesn't like the function call for whatever reason. I'm a little confused because this is in our update function where all of our, see that that's in our update function where this is in our completely separate function, lowest surrounding occupants function. I don't know why it's crashing. I want to comment out most of this, or all of this actually, and then say that all this function does is assign our lowest surrounding occupants to be the first parameter. So we're going to see if our actual function body is the one responsible for crashing, which it is not. So I'm wondering if you attempt to call global lowest surrounding occupants a nil value. Attempt to call global. Attempt to call global. Lowest surrounding occupants. Now we've got, what if we have literally nothing in the body of this thing? We still crash. So I mean, all of our functions are here. It's right with our other functions. So why is it not working? What do we try? So I want to just change the function name to see if it is in fact crashing on the function call, not the variable. Oh, it just worked there. So we have a problem here because of our function call being the same as our function variable. I'm wondering if we print up the extra S on the debugging here. Hi, sweetie. Hi. No, actually. Okay, let me turn back on. Let me turn back on this. Hey, sweetie. I think it might be messing up because we had a function that's the same title as a variable, which I didn't know you couldn't do, but I guess it makes sense. Now we're calling this function on the movement origin row, movement origin column, but we took out the part where that function actually did anything. So let's go back and turn that back on, and we'll just turn all that back on and then see if we crash or not. And we don't. It's just giving us the wrong number. Should be 11, not 13 here. Because this is, damn it. It got populated, but it got populated with not the lowest. So something's wrong in our logic. So if we take a look at our middle cases, now I think the else if is actually screwing us here. Because it's only actually checking one stone. So we actually need to break these out of the else ifs and just do if statements all around. So if we say that this is just an if and everything is just an if here, come on, everything is just an if here. And we'll have to go do our edge cases and everything as well. I didn't think about this. But yeah, we can't. This only gets called once upon clicking, so if we have an else if, we only check this very first thing, which is our top stone. So we were actually only assigning our top stone, which was our 13. So if we do ifs instead of else ifs, at least for our middle cases right now, I'm hoping that'll fix it and will actually be lowest surrounding occupant of 11, which we are. Booyah! Say hi, Rosie. Say hi. We did it. Oh, right. So we've only tested middle cases. We know we need to go back here and take all of these out of our else if blocks as well. So we know we need this to be an if, not an else if. We know we need this to be an if and not an else if. Yeah, we just need to make all these ifs and not else ifs because it was evaluating only the first one and then exiting the loop. Not a loop, just a statement branch. Then if this works, we can go ahead and try taking out that nil line and seeing if that messes anything up. Or combining it as an expression so we don't have to repeat ourselves. Okay. We're all broken out of those else ifs. Now let's change one of our tester stacks. When we make our tester stack, let's give us a tester stack of 8 around us. Then we'll see if we pick it up. Our lowest surrounding occupant is 8. So that seems to be working. So now we still haven't actually fixed our problem. So look, we've got an 11 stack here. Our lowest surrounding occupants would be 11. Now, that would mean that when we pick this up, we shouldn't be able to pick up more than 3 because we can't place more than 3. So we have 4 stones in here, yet when I press enter, it goes to movement event 3, and that means we don't have any legal moves left, so we're locked. So it hasn't fixed our problem just yet, but we have the variable to fix our problem right here with our lowest surrounding occupants. So once we, what is it, going into movement event 3? Yeah, at the end of movement event 2, when we press enter at the end of movement event 2, we only need to advance to movement event 3 if our mouse stones is our mouse stones plus the lowest surrounding occupants wouldn't be higher than 14. So we can go ahead and implement that. That's at when I say the end of movement event 2. Yeah. So we'll go to movement event 2. Okay, so at the end of movement event 2, when we go to hit enter, which is right here, if we have a legal move, see, this is not what I expected here. If we only have one legal move, we make sure that our occupants plus our occupants can't be more than 14. So I think we can actually get rid of this altogether. But I guess let me see what our legal move count gets assigned from. So legal move count. Where do we actually do this? It's literally just counting how many legal moves we have. Hi, sweetie. Hi. Hi, sweetie. We're almost done. So yeah, this was to ensure if we only had one legal move, we would need to make sure that the amount of stones we place isn't there, but we actually want to, we actually don't need to do this anymore because we're doing it based on this field called lowest surrounding occupants, which if we have even one legal move, that will get populated, so we shouldn't need to do this anymore. So we should be able to get rid of this. So I want to comment this out for now. I want to go to where we do our legal move count, and we don't necessarily need this anymore. Gosh. So this is what happens. This line of code is what happens if we have more than one legal move or no legal moves. What the heck are we doing here? If our occupants plus our grid occupants is greater than 14, then we're falsifying that grid. But why upon an enter would we be falsifying? If it's a legal move. Okay, so it's searching through every single legal move, and if by the time we lock in our stones, we have more than the amount of occupants that it can carry, it's going to go ahead and falsify that legal move. That makes sense. But we do need to I think we can get rid of this, and we can just say if yeah, we don't need to check this legal move, but we do need to see if our mouse stone occupants plus so we have a variable called lowest surrounding stones, and we need to add a case where if we press enter, we don't actually change the movement event. So that's what we're trying to prevent. So how do we actually go about that? Well, we can say cycle through the grid. Wait, hold on. What are we trying to do here? How do we limit it? We only want to... Yeah, see, this is actually not right. Because this is allowing us to lock in a legal move, a legal amount of stones. I kind of feel like we just need to do this all over again. So we don't want to update this just upon an enter. We want to do it only if we have, here, let's just go for it. Hey, kitty. Hi, sweetie. Hi. Yeah, we just got to do this a little differently. So we can first check and see if we have more stones in our hand than would be a legal move. So we're going to say if our mouse stones dot occupants plus this variable of lowest surrounded occupants, if that number is greater than 14, then we know we want to do nothing. because it wouldn't be a legal move. So we can't move on to a movement 3 if you don't have any legal moves. So instead of doing this like we did before and making this do nothing in the illegal case, we're going to say if it is smaller than 14, actually do something. And if it's smaller than 14, we want to cycle through and make sure that the grid this is wrong, man. No. Okay, so movement 2, we already have the stones in our hand. So we just need to check. I don't know how this code was working. Like, this doesn't make sense to me that this code was actually working. I'm a little confused, to be honest. But if our mouse stone occupants plus our lowest surrounding occupants is -14, we know we want to go ahead and move movement events. I don't get why we were checking legal move status on every grid. And if it was a legal move, that doesn't make any sense to me. But we don't have to do that. Just because we did it in the past doesn't mean it was necessarily right. Just because it worked doesn't mean it was necessarily right. So if what we have in our hand plus the lowest surrounding occupants is smaller than 14, then we're going to go ahead and change our movement event 3. Now, is that all we need to do? Now we do need to falsify. Yeah, because we do need to do this still. We would still need to falsify any legal move that would be illegal. Yeah, if we have more than 14 occupants in that space, we would need to make that move illegal. So before we do this, we would say cycle through all the legal moves, and if those grids plus our milestone occupants are greater than 14, we are actually illegal. But then we're going to go ahead and change ourselves to movement event 3. And if enter is pressed and we don't have any legal moves, once we lock in our moves, or once we lock in our stones, it shouldn't do anything. So let's pick up too many stones here. We've got 5 stones, which can't be placed in this, or this, or this, or this. So let's go ahead and hit enter, and hopefully it won't move us to movement event 3. It does not. Now, the most amount of stones we can pick up is 4, because, is 3, because 3 plus 11 would be our max of 14 stones. So let's have 3 stones in our hand. Now, four stones in our hand, pressing enter doesn't move us to movement event 3. But if we have 3 stones and we hit enter, which I'm going to do right now, we are still in a movement event 2 because we forgot an equal sign. But if we have 2, we are in fact able to carry 2 over. And 2 can't go in a 13 stack or a 13 stack, but it can go in an 11 stack. So I think all we have to do is have the greater than or equal to 14 right here. Actually, not right there. If mouse stone occupants plus surrounding occupants is smaller than or equal to 14, then we can go ahead and move a movement event. And if our mouse stone occupants plus the grid's occupants is greater than 14, then it's legal move false. That should be right. I think we did it. I think we did it. Because now, if we have 5 stones, hitting enter does not advance us. Having 4 stones does not advance us, but having 3 stones, because 3 stones plus our 11 here, would mean that we have 14. So now see how these are false, yet this one is true. And yet if we pick up and dump, so we only have 1 stone, we can actually dump them in any location. So now we can't get stuck, and we can kind of like, once we lock in our stones, it locks in our actual legal moves. So I think we did it. That's the bug fix. That went really smoothly, as all things considered. So one thing I wanted to do was combine those nil statements. I'm gonna get rid of all this junk because we don't need it. And then we're gonna say yeah, we didn't need this legal move count. We might use, I don't think we use that anywhere else. Yeah, we don't use this anywhere else, so I'm pretty sure we can just kill it. Now, I want to tidy up that function a bit, because right now it's a lot of code. Yeah, this one function is, Jesus, how many codes? How many lines? From 521 to 321. That's 200 lines of code for this one function. And we had to fix it by putting a weird S here because we couldn't use the same variable name as a function, which now we know. So what do we do here? We're gonna do lowest surrounding occupants function versus lowest surrounding occupants variable. Now, lowest surrounding occupant, I'm just gonna call our function lowest surrounding occupant, and our variable is still lowest surrounding occupants. So when we call our function here, lowest surrounding occupant, come on. Looking for our actual function call. Oh God. Come on, dude. Here. Okay, let me just make sure it doesn't crash. Okay. Now, yeah, I want to see if we can tidy up this function real quick. Okay. So here, instead of, see how we're doing the same thing twice? We're assigning our lowest surrounding occupant based on this. We can combine, we should be able to combine this by saying some weird noises going on outside. I'm going to actually commit this right now before we change this and say added working lowest surrounding occupant function. Get push that bad boy and then say we're gonna try to do this. So if it's nil or if it's lower than our current occupants. So we're going to say or our grid is lower than our occupants, then go ahead and do that. So we should be able to get rid of 3 lines of code per block here if this works. So we just need to make sure we do this and say or. And I'm not entirely convinced this will work because Lua is kind of weird with the nil values, but I'm thinking it should work. So if it's nil or if it's this, then we're going to do that. Get rid of these 3 lines. So that tidies it up quite a bit. So instead of 200 lines of a function, it should be shorter. Or this. Riveting, I know. Or this. Yeah, we're getting rid of, this will cut it almost in half. Our total lines for this function almost in half. If it works. Uh-oh. I just realized we've been doing this wrong, but we only need to delete those 2 lines because we still need an end to close these. Wow. Yeah. It ain't glamorous work, but it doesn't pay the bills either. Okay. Let's keep going. I'm gonna learn Vim. That's next on my list. If this doesn't work, we'll just revert to our commit. But I'm thinking it should work. Wow, god dang. Coming up on it. Still on edge cases, but... Almost done, end in sight. We just have to hope it works now. Cool. Let's give it a shot. Should do the same thing. Okay. We are not allowed to lock in that many stones. Not allowed to lock in that many stones. We can lock in 3. So we can do that. And then if we lock in only 1 stone, we get 3 different legal moves. So that's looking like it's working. So we went from 200 lines of code to here's now 473. 473 to 321. 473 to 321. So we were 200 lines. Now we're 152, so we cut 52 lines out of that function. Which is nice. We can actually go for a little more here. make sure you should be good. Nice. Cool. We did it. We're gonna say refactored lowest surrounding occupant function to have 50 less lines. And we're gonna push that bad boy. Cool. So next up, now that we've got functions to populate the board in a bunch of different ways, it's gonna be a bunch of bug hunting for any crashes. And then once we're fairly confident that it's working fine, then we can worry about win state. And then we're in the home stretch. I know I've been saying that, but now we really are, because we fixed these major bugs. We still can't move over a stack. That is, like if we carry, if we carry stones into a 13 stack, we can only carry one stone into a 13 stack at this moment. When in reality, we should be able to carry more stones if the stone past that 13 stack can hold the rest of the stones. Then we should be able to pass over it. I don't know if we want to add that. Ideally, we do add that. It's just, I'm a little daunted by it, which means we should probably just do it. And the reason for me not wanting to do it is because I don't know if I can pull it off. So I don't think that's a good reason to not do it. Either we try and we fail, then we give up on it, or we try and succeed and then it's in the game. So I think we will be working on that. Yeah, we'll take tomorrow and try to brainstorm how exactly we're going to make that work. But I think it should be possible. So we'll get to it. And then we'll do polishing, or we'll do win state. It's going to be kind of difficult to write the algorithm to determine a win state, but we can do it. I'll see you guys tomorrow.